Up until today, in order to prove that triangles are congruent, you needed all three angles congruent and all three pairs of sides congruent. If you notice today, what we're going to be doing is we're going to cut down your work significantly. So notice here in this introductory part that we have, if all corresponding angles and sides of two angles are congruent, then the triangles are congruent. However, and this is the key for today, you can prove the triangles using fewer parts. So, for example, if you look at the names give away what we're looking at. So if you look here, you've got side, 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 or we shorten it to be SSS. What that means is if you have three sides of one triangle congruent to three sides of another, then the triangles are congruent. So when we look at our picture, we have one side marked here, we have a second pair marked here, we have a third pair marked at the bottom. Since we have three pairs of matching sides, we can use that the triangles are congruent by side, side, side. So what we have in this fill-in over here is we have segment AB is congruent to segment ED. It is marked as such. The second pair we had was BC. Segment BC is congruent to segment EF. Then we have the third segment across the bottom. AC is congruent to segment DF. So again, we have three pairs of congruent sides. Then we can say that the triangles are congruent. So the first one we can name however we want. But A is where the side marked with 1 and 3 comes together. So the angle with 1 and 3, those come together at D. So triangle ABC corresponds with D. And then we moved up the triangle to go to B. So we move up the triangle across that side marked with 1 mark to go to E, and then F by side, side, side. Now, just a reminder, for your congruency statement, so for this statement, order matters, okay? You have to have the first one in whatever order you want, but then the second one, your corresponding parts have to match. So again, all you need, 3 congruent sides, you can show those triangles are congruent. You also could have the option of 2 congruent sides, and notice where the angle is located in the name. So the angle is between the sides in the name, also here in the abbreviation, which means when we look at the sides marked here, it's the angle that's between the sides. Or if we look at the sides here, it's the angle that's between the sides, or that's formed by the sides. So another way to say that is that it's an included angle, okay? So if we look at our 2 sides, we have AB is congruent to segment BE. Then we have the angle B is congruent to the angle E, and since we only have 1 angle at those vertices, we can just use that single letter. And then we also have BC, segment BC is congruent to segment EF. So again, you've got the side, the angle between them, and the side. So we could say triangle ABC is congruent to triangle DEF by side angle side. Okay, so this is the first 2 of 5 different types of ways that we can prove triangles are congruent. So when we look at our pictures below these examples, what we're going to look at is we're just going to determine whether or not the triangles can be proven congruent by either side, 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 or side angle side. Notice it says if possible. So there might be times which it's not going to be congruent. So if we look at number 1, we've got 2 sides, and then where those 2 sides come together, we have that angle marked. Same thing here. We have the 2 sides where that angle comes together. So by side angle side, we can show, and notice it also says to write a congruency statement. So if we look at that congruency statement, we've got triangle, and I'm going to go ahead and call the first one YTQ. Y is the marked angle, so it's going to correspond with K. Then we moved along the side marked with 2 marks to get to the next point. So we're going to go to P and then C. Again, order matters. All right, if we look at number 2, we have this shared side in the middle, so we know for sure it's congruent on each side for those triangles. So using side, 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 we could state that we have triangle ADC is congruent to, and notice up here, A is where the side marked with 1 and 3 come together. So that's going to correspond with C. We move to D, so you're at B and A. Again, when you guys look at these, you can change the order of the first triangle, but then the second triangle will also change the order. Now, this one is a little bit tricky. If we look at number 3, I'm going to outline this one, and I'm going to mark the things that we have here. Oops. Hold on one second. I marked something that wasn't true. Okay, so we have this and this. Okay, and then we also have, and I'm going to do this in a different color here, we also have this triangle here marked. And so when we look at this, I'm going to move this triangle away just for a second. And again, we have this and this marked. Now notice, I'm going to move this back and forth for a second. If we look at that bottom segment is shared again. Okay, so if we put that back together, it's shared, which means that it's using the reflexive property, we can say that these are congruent. And so it is a reflexive, it's just a different way. It's not a shared side in the middle, it's a shared side at the bottom. So now we can say, if we look at our pictures, we have a side, another side, and an angle between. So using side, angle, side, I can now say that triangle JMK is congruent to, and J is the one up at the top, so triangle L, and then we went down to M, so we go down to K and M. Okay, if we look at the next picture, where those two sides come together, it's not that angle that's marked, so this is actually not possible or not congruent. Okay, because we cannot use that angle unless it's between those two sides. For number 5, we've got that shared side in the middle. So using side, 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 we can show that triangle CEF is congruent to, and again, C is where the 1 and the 2 come together. The 1 and the 2 comes together at D, and then we go to E and F. If we look at number 6, we see these parallel lines here and here. So if we look at this transversal cutting, we've got that corner angle, that alternate interior angles. And so now we have the sides, and then we have another pair of sides with the angle in between. So we have side, angle, side, and we can say triangle DAJ is congruent to triangle, and D is the one that's marked, so it goes with E. A is the same as A, they're vertical angles, and then we have M. And then if we scroll down to number 7 and number 8, again, we look at these two, that's the angle that we need. It's not the angle that we have, so not congruent. And then here for number 8, we have the vertical angles. And again, that is the angle that we need. So by side, angle, side, we can say that triangle CAB is congruent to, and C corresponds with C. We move along the side marked with 2 to get to A, so we would match it up with E, and then D. So we're just matching up our pieces. So again, to use side, 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 we need all 3 sides marked as congruent to the other 3. We need, for side, angle, side, 2 pairs of sides with the angle that's in between them, or the angle that's formed by them. The one that's going to take us a little bit longer is using side, side, side in the coordinate plane. Now, we can't figure out angles in the coordinate plane except for possibly 90-degree angles, which we're not going to worry about. But what we're going to do is, in order to determine side lengths, we have to do the distance. Okay, and so if you remember our distance formula, we've got the 2 points, we're going to subtract, and then same thing, and a subtract, and then we throw in the x's together. Don't forget that's a plus in between, the y's together, and we're going to simplify. Okay, so when we look at this, I'm just going to go ahead and set up this formula, the big square root, and we're going to subtract. Okay, so for PQ, our x values are 5 and -3. Our y values are -4 and 7. So then when we simplify, we get 8 squared plus, and then this is -11 squared. And remember, whenever you square a number, it turns positive. So the first one we are going to have as 64 plus 121, which then is going to give us the square root of 185. And I'm going to leave it like that. You can change it to a decimal if you want. It's just extra work. Okay, so for QR, I'm going to go ahead and do the same thing. I'm going to set up my formula. Okay, don't forget about our negatives. Be careful there. So QR is going to be -3 and 0. Those are our 2 x values. Our 2 y values are 7 and 2. When we simplify, we get -3 squared and then 5 squared, which is going to give us 9 and 25, which is then going to give us the square root of 34. The last one, PR, we've got the big square root. Again, we're going to go ahead and square those, subtract them. Again, put in our x's. So we have, for our P and R, we have 5 and 0 for our x's. For our y's, -4 and 2. So that's going to be 5 squared plus -6 squared, which which is going to give us 25 plus 36, which is then the square root of 61. Okay? Now, notice this is a scalene triangle. It just doesn't help us because, again, what we're trying to figure out is whether or not those triangles are congruent. So if we look at x and y, I'm just going to kind of put a little bracket here to help me kind of make sure I'm using the right points. So again, I'm going to set this up. Okay, I'm going to input my x values for x and y. So -2 and 9 are my x's. My y's are -1 and 7. So I have -11 squared plus -8 squared. So I've got 121 plus 64. And notice that's the same as what we had originally, so 185. So far, we have two sides that are congruent. Okay? We need all three though, so we have to keep checking. So we're going to go ahead and we're going to plug in again our x's. So we have 9 and 3 for our first pair. For our y's, we have 7 and 2. When we simplify, you get 6 squared and 5 squared, which is then going to be the square root of 61 when we simplify. So again, these two are now the same. So we have to go ahead and check our third one to make sure that all three are the same. It's looking promising. So we've got to go ahead and plug in our x's for x and z, which are -2 and 3. Our y's are -1 and 2. When we plug in -5 squared plus -3 squared, it's going to give us 25 plus 9, which again is the square root of 34. So these are congruent. Now here's the thing: don't go that far and then like forget to answer your question. So it says, are the triangles congruent? Yes, they are congruent by, and we have three sides that are congruent. So side, side, side. And then notice it does say to write a congruency statement. So what I would recommend is rather than just trying to just eyeball it, I would go ahead and label PQR and triangle XYZ. Now the reason I say that I would go ahead and draw our picture is because we know that PQ is the same as XY. We figured that out right here, PQ and XY. Then we figured out that QR, so QR is the same as XZ, and then we have the final three, or excuse me, the final pair. And so now I can say triangle, and I can go ahead and label the first one however I want. PQR is congruent to, and P is where the 1 and the 3 match, so wherever the 1 marking and the 3 marking come together. So 1 and 3 come together at Y, so triangle Y. And then to go to Q, we went down along the 1 mark, to go up along the 1 mark to get to X, and then Z. But I would draw the picture and label rather than just trying to eyeball it, okay? So on your own, I'm going to have you guys try out this last problem here, figure out if they are congruent. So keep in mind here, for the last one that we did, we had to prove all three sides were exactly the same. Not close, exactly the same. As soon as one was not the same, we would have not congruent, okay? So we have to prove all three are exactly the same. So go ahead and try this one out. Once you're done with that, as always, ask questions if you have them, and let me know where I can help. Thanks.